Hello my dear friends, welcome to this session of Is Matter Around Us Pure? I welcome you to Learn Is Planet to attend this session. In this session we are going to discuss about the concentration of solution, how the concentration of a solution is expressed, or what is meant by the concentration of a solution. We'll be also discussing about the solubility of salts in water. See, what is solubility? What are the factors affecting solubility? We'll be discussing these things or these concepts in this session. So let's start our session, students. What is meant by concentration of a solution? See, a binary solution has two components or constituents. Say I'm talking about the solution of salt and water. So it is a binary solution. The one which is present in smaller amount or less quantity is what? Solute. And the one which is present in greater amounts or large amounts is solvent. So there are two components or constituents. The relative amounts of solute and solvent in the solution, either by mass or by volume, represent the concentration of the solution. The relative amount of solute or solvent, right? Say how much solute is present in 100 grams of solution or how much solvent is present in 100 grams of solution. So this relative amount of solute and solvent present in the solution is given either by mass or by volume. Now depending upon the concentration, that is depending upon how much of solute is present in the solvent or whose composition is more, depending upon these, solutions are of different types like dilute, concentrated, saturated, unsaturated. Say a dilute solution, we talk of dilute H2SO4. Dilute H2SO4, what does it mean? It is a very small amount of H2SO4 and or in large amount of water, dissolved in large amount of water. So that makes the dilute H2SO4. Concentrated H2SO4, say the amount of H2SO4 will be more. So that makes the concentrated H2SO4. The solution having small amount of solute is said to have low concentration, and it is also known as dilute solution. And a solution having large amount of solute is said to be of high concentration, right? Say small amount and the large amount. Okay, that is a concentrated solution. Now let's discuss about the methods for expressing the concentration of a solution. Concentration of a solution is normally expressed as mass percent or volume percent. How is this mass percent calculated? Mass percent of a solution is number of parts by mass of one component. Now that component can be either solute or solvent. We'll take a simple solution, that is a sugar solution. So what will be the mass percent? Mass percent of sugar if I want to calculate. So mass percent of sugar, that is the number of parts by mass of sugar per 100 parts by mass of solution. So what is the mass percent? Mass percent of one component per 100 parts by mass of solution. So if I have to calculate mass percent of A, what will be the thing? The mass of A, that is the weight of A by the mass of A plus mass of B into 100. That is indicated by W. Likewise, the mass percent of B will be the mass of B by mass of A plus mass of B into 100. So this is the way we can calculate the mass percent of any component in the solution, right? So it is the weight of the solution. This is mass percent. Say if I write 6% volume by volume, or I should write 6% weight by. 6% weight by weight. What does it mean? It is 6 grams of solute upon 6 plus the rest of the it. Whatever is the thing, say I can take it as 94 grams into 100. Right? So this is 6% weight by weight. This is the weight of the solution. So it is a relative mass of one of the components per 100 parts by mass of solution is the mass percent. There's another thing. There is another thing by which we can express the concentration of a solution. That is the volume percent. Volume percent of a solution is the number of parts by volume of one component. That is, it can be either solute or solvent per 100 parts by volume of solution. Right? So volume of any component, if it's salt solution, or we can take it as alcohol and water. I should take some liquid here. Let's take up alcohol plus water. So alcohol and water. So the volume of alcohol divided by the volume of alcohol plus volume of water into 100 will give the volume percent of alcohol. Likewise, if there is volume of water divided by volume of alcohol plus volume of water, this will give what? This into 100. This will give the volume percent of water. So these are the methods by which we can express the concentration of a solution. Let's take up one or two numericals related to this. The question here says, calculate the masses of cane sugar and water required to prepare 250 gram of 25% solution of cane sugar. Now what is the formula? Formula is mass percent is equal to here I can take mass of sugar by the water present by the sugar plus water, the mass of sugar plus water into 100. Now we are provided with the mass percent. How much mass percent is given over there? 25%. That is equal to the mass of sugar we don't know, but we know the mass of solution. Say it's a binary solution. Binary means there are two components. What are these components? These are sugar and water. So this complete will give the weight of the solution. So we know the solution. How much of solution is there? It is 250 grams. So weight of solute divided by 250 grams into 100. Now what will be the weight of sugar here? What will come? It is 25 into 250 divided by 100. This simple math calculation you can do, right? What you'll be getting here? It comes out to be 62.5 grams, right? Just do the calculations. So what is the weight of sugar in the solution? It is 62.5 grams. So what will be the weight of water in the solution? We can make the equation. What is the weight of solution? It is 250 grams. This is equal to the weight of solute plus the weight of solvent. So here 250 grams, 250 will be equal to the weight of solute, that is 62.5 grams plus of weight of water. So what will be the weight of water in this solution? It will be 250 minus 62.5. What will be the answer of this question? It will be 187.5. See, the solvent is present in large amount, is greater amount. This is present in lesser amount. This solute, solute. Sugar is present in lesser amount. So sugar is what? Solute. And water is what? Solvent. The one which is present in lesser amount is solute, and the one which is present in greater amount is solvent. So what is the amount of solute? It is 62.5 grams and water is 187.5 grams. Let's take up one more question like this. See, this is a very simple question. A solution has been prepared by dissolving 5 gram of urea in 95 gram of water. What is the mass percent of solution in water? What is solute in this solution? Urea, because it is present in lesser amount. What is solvent in this solution? It is water, because it is present in greater amount. So how will we solve this question? Let's write the formula first. It is mass percent is equal to, here it will be the mass of urea divided by the mass of urea plus the mass of water, the weight of water, and that is equal to into 100 we have to do, right? Into 100 or multiplied by 100. Mass percent we have to find out. That is equal to, what is the weight of urea in the solution? 5 grams by 5 plus 95 into 100. What will it come? It would be 5%. So it's a very simple question. This is the way you can find out the mass percent, right? Let's take up one more question. The question says that a solution contains 50 ml of alcohol mixed with 150 ml of water. Calculate the concentration of this solution. How we will calculate? Here both are liquids, so we have to calculate the volume percent. Now what is the volume percent? That is equal to, here in this case, what will be the solute? Alcohol will be the solute and water will be the solvent. So what is the volume of alcohol in the solution? It's 50 divided by 50 plus volume of water 150 multiplied by 100. So this will give the concentration. Let's do the calculations. Volume percent is equal to 50 by 200 into 100. What will come? It is 225. So what is the concentration of the solution? The concentration of the solution is 25%. We can write it as volume by volume. So this way we can calculate the mass percent as well as the volume percent of the solution. And this is how the concentration of solution is expressed. Right? Now, do you know what is strength of a solution? The concentration of a solution can also be expressed in terms of strength. Now, what is the strength? Strength is the amount of the solute present, or amount of the solute in grams present in 1 liter of solution. That's it. That will give the strength of the solution, right? So it's just, I am just introducing this term strength. So the amount of solute present in grams, or amount of solute in grams present in 1 liter of solution is what? The strength of the solution. This is how, this is one of the method to express the concentration. Let's take up numericals related to the strength of the solution. So you are asked to find out the strength of the solution. The question is, calculate the strength of a solution containing 5 gram of glucose in 200 ml of solution. What is strength? Strength is nothing but the mass. What is it? It is the amount of a substance in grams present in 1 liter solution. That is what strength is. So here, what is given? 5 gram of glucose in 200 ml water. What is the mass of glucose? It is given as 5 gram. What is the volume of solution? It's not water, it's solution. So what is the volume of solution? It's 200 ml. So what will be the volume in liters? The volume of solution in liters will be equal to how much? 200 divided by 1000. How many liters will it be? It will be 0.2 liters. Now we can find out the strength of the solution. So strength of solution will be equal to how much? It will be 5 gram divided by 0.2. Now it comes out to be how much? What is the strength? It is 25 grams per liter. So what is the strength of the solution containing 5 gram of glucose in 200 ml of solution? It is 25 grams per liter. So strength is nothing, students. It's just the amount of substance in grams present in 1 liter solution. That's it. So these are the methods how the concentration of solution is expressed. Now depending upon the concentration of solute in the solution or the amount of solute in the solution, there are different types of solutions. When the amount of solute is very, very less, the solution formed is a dilute solution. When the amount of solute is very high or it is more, then it is the concentrated solution. Right? No matter what, students, always remember the solute is the one which is present in lesser amount, and the solvent is the one which is present in greater amount. Right? Say if I'm saying it's 2 ml H2SO4 in 1 liter, I can take, or I can take 100 ml. Here this can be, say, 25 ml H2SO4 in 100 ml. Of what? This is in 100 ml of water and in 100 ml of water again. So what will be the weight of complete solution here? It will be 102 ml. Not it will be 102 ml of solution, and this will be 125 ml of solution. But in this, the proportion of solvent is more, the proportion of solute is less. But say this will be the dilute solution because the solute is very, very less, and this will be the concentrated solution because the solute is more, comparatively more. So when the concentration or when the amount of solute in the solvent or in the solution is more, then it is the concentrated, and when it is less, it is dilute. Now let's take up the saturated and unsaturated solutions. The saturated and unsaturated solutions. Now a solution in which more quantity of solute can be dissolved without raising its temperature is called an unsaturated solution. So if I'm taking sugar in this beaker and I'm taking some water, let's take it as 25 ml. Right? Now to this I am pouring sugar and I am dissolving it, keeping on dissolving it. Now this solution in which sugar can be dissolved, more of the sugar can be dissolved, the solution formed is called as what? Unsaturated solution. Here more of sugar can be added to this. Or it can be also defined as a solution which has less than maximum amount of solute present in it at a given temperature is unsaturated. See, every solution has got a limit. I told you that you can't keep on dissolving sugar in a glass of water. There will be a limit or there will be a level reached when no more sugar can be dissolved. Okay. So when no more sugar can be dissolved, that will form the saturated solution. So until you can dissolve a solute in the solvent, that is called as the unsaturated solution, or an unsaturated solution is a solution in which more of solute can be added without raising temperature. See, this solubility is dependent on temperature. And a solution in which no more solute can be dissolved at that temperature is called as saturated solution. Say in which more of solute can be dissolved is called as unsaturated solution, and in which no more solute can be dissolved is called the saturated solution. Right? See what happens if I'm just dissolving sugar in this in water in this beaker. Right? Now, the limit has reached after which no more sugar can be dissolved. Then, if I am heating this solution, sugar solution which I have made. What will happen? The saturated solution will change to the unsaturated solution. On heating more of the sugar, I can add more of the sugar to it. Say a saturated solution can be converted to an unsaturated solution on heating. Why so? Because if I'm heating, I'm providing the heat energy. Now this heat energy provided will, what it will do? It will transfer energy to the molecules. The molecules will start moving. As the result of which, what will happen? More space will be created between the molecules. So more of the sugar can be added, right? You must have seen, say, the sugar syrup. When it cools down, it gets solidified. When you heat it, it melts. See, when heat is applied to any solution, or when any solution is heated, what happens? The particles gain energy and they start moving haphazardly. As a result of which, the interparticle space, what is this interparticle space? It is nothing but the space between the particles. It increases. So now within this space, more of the solute can be accommodated, or more of the solute can be fitted, right? So remember, what is an unsaturated solution? A solution to which more quantity of solute can be dissolved without raising temperature is unsaturated solution. And a solution to which no more solute can be dissolved at that particular temperature is called saturated solution. Say, if I'm dissolving sugar, it will become saturated. Say, after a limit, when the sugar is added, it will not be dissolved. It has become saturated. But when I'm heating it, when it is heated, what will happen? The molecules will start moving. Why? Because they are gaining energy. They will start moving, and the interparticle spaces, thus increasing the interparticle space, so that in this space more of the sugar can be accommodated, or more of the sugar is dissolved, right? So this is about saturated and unsaturated solution. A maximum of 32 grams of potassium nitrate can be dissolved in 100 grams of water at a temperature of 20 degrees centigrade. It means what has been formed? It is a saturated solution of potassium nitrate at 20 degrees centigrade. So this saturated solution of potassium nitrate that is KNO3 is formed. Now this is at 20 degrees centigrade. How much of potassium nitrate is there? 32 grams. And how much of water? 100 grams. Now when this solution is heated, then this solution will turn to become, or the solution will become unsaturated. I've told you, when the heat energy is supplied, the molecules gain energy, they start moving haphazardly, and more of the solute can be accommodated then, or more of the solute can be dissolved. So whenever you have to mention the saturated solution of any compound, you need to mention the temperature also. Now let's take up another concept, that is solubility. What is solubility? Solubility, what is it? The maximum amount of a solute that can be dissolved in 100 grams of the solvent to form a saturated solution at a given temperature is known as solubility of that solute in that solvent. It is simple. It is just the maximum amount of solute that can be dissolved in 100 grams of solvent and at a particular temperature. Now this solubility of salts and solvents are affected by change in temperature. Obviously, say when the temperature increases, more of the salt can be dissolved in a particular solvent. So it means with the increase in temperature, the solubility increases. So while expressing the solubility of a substance, we should specify the temperature also, right? What is the effect of temperature on solubility of salts? Solubility is what? It is the amount of solute present, or it is the maximum amount of solute present in 100 grams of solvent at a particular temperature. Now, how this temperature affects the solubility of salts? The effect of temperature depends upon the heat energy changes which accompany the process of dissolution of salt in the solvent. See students, there are salts, say when this salt is dissolved, say if I'm taking NaCl, if it's dissolved in water, it requires energy from outside. That is, it is taking up energy, and this process is called as endothermic. Endothermic means taking energy in. And there are salts like, say, lead carbonate. This, when dissolved in water, releases energy. Sorry students, it's lithium carbonate. When this is dissolved in water, it releases energy, or the energy is this energy evolves, or energy is evolved. So this process of dissolution of lithium carbonate in water is which process? It is an or is what type of a process? It is an exothermic process. Right? So there are salts which, when dissolved in a solvent, absorb energy. Thus the process is what? Endothermic. And there are salts which dissolve in water, evolving energy or releasing energy. And that is what process? The exothermic process. Depending on this, there will be the effect of temperature. Effect of temperature on endothermic dissolution process. Salts like sodium chloride, potassium chloride, sodium nitrate, ammonium chloride, etc. dissolve in water, just many other salts like this, dissolve in water with the absorption of heat. That is the process is endothermic, right? Say NaCl, sodium chloride is NaCl. When it is dissolved in water, there is strong force of attraction between Na plus and Cl minus ions. This force of attraction is very strong. When it is dissolved in water, this force of attraction, when it is dissolved in water, what happens? It absorbs energy, or for its dissolution into water, it absorbs energy from outside. This energy is needed for breaking up this force of attraction. When the temperature is increased, more of the bonds will be broken and the dissolution or the solubility of these salts in water increases. When the temperature is increased, more of the NaCl molecules will be broken down into the ions. So for the, this is just for your explanation. This is just in order to explain you students. So the solubility of these salts in water increases with the increase in temperature. What is solubility? It is the maximum amount of solute that can be present in 100 gram of solvent at a particular temperature. That is solubility. Now when the temperature increases, the solubility of such salts which dissolve in the solvent with the absorption of heat increases, right? Now there are salts like lithium carbonate, sodium carbonate, monohydrate. It is Na2CO3H2O. Cerium sulphate dissolve in water with the evolution of heat. See, when these salts are dissolved in water, the heat is evolved. It means it is an exothermic process. Heat is evolved. So with the increase in temperature, their solubility decreases. Remember these 2 points. That is, the effect of temperature on the dissolution of salt depends upon the type of process. If it is endothermic, with the increase in temperature, the solubility increases. If it is exothermic, with the increase in temperature, the solubility decreases. There is a question over here that is 12 grams of potassium sulphate dissolves in 75 grams of water at 60 degrees centigrade. What is its solubility in water at that temperature? Right? At the same temperature, the solubility is asked. What is solubility? It is a maximum amount of solute present in 100 gram of solvent at a particular temperature. So this 12 grams of potassium sulfate is present in 75 grams of water. Or 75 grams water contains how many grams of potassium sulfate? 12 gram. So 100 gram of water will contain how much of potassium sulfate? It will be 12 by 75 into 100. Right? So what will be the answer? It's 4, 3, 4 and it comes out to be 16 grams. So what is the solubility of potassium sulfate? It is 16 grams. That is 16 grams of potassium sulfate can be dissolved in 100 grams can be dissolved in 100 grams of water. At what temperature? At 60 degrees centigrade. Right? So students, remember, what is solubility? It is the maximum amount of substance that can be present in 100 grams of a solvent at a particular temperature. Right? So this is how we express the concentration of a solution, what is saturated and unsaturated solution, and also the solubility. Now I'll be concluding this session, students. In the next session, we'll be discussing about the physical and the chemical changes. About the changes, that is, what is a physical change and the chemical change, with the examples. Right? Thank you, students, for being with me, for listening patiently. Now just go through your book. It's a very, very easy concept. It will be clear to you. Right? Thank you once again and do have a nice time ahead.